Right, so as Matej shared in his slides, you have two LLMs. You have one LLM that is focused on reading the text and reasoning about it, which is this generative LLM that's going to produce the response. And then you have another LLM that is focused on finding the information and finding the knowledge that matches what you're after. So when your data comes in right now, this retrieval LLM is actually stateless. You don't train it on your data in any way, shape, or form. This retrieval LLM is already trained on a lot of public data. Your data simply flows through it, and this retrieval LLM, in layman terms, converts it from language space, English, Chinese, Japanese, French, into a meaning space. We call these meanings, we call them embeddings. If you hear the word embedding or the word vector, this is the numerical representation of the meaning of these words by the computer. And then we store all of these meanings in a vector database or a knowledge database. And by the way, our name is Vectara because of that. It borrows from that to that. And then when the question from the user comes in, you very quickly convert that question also from English, French, German into the vector meaning space. And these systems, which we call vector databases, are very good at doing the matchmaking and then give you back the facts that most represent the knowledge that you're after by that question. And then now we give these facts, using real-time prompt engineering, we give these facts to the generative model, and we tell the generative model, answer the question, but only answer the question using these facts. Don't use it with whatever is in your brain. Forget what's in your brain. Leverage your knowledge of the language of how to read. Leverage your knowledge of the domain, legal, engineering, medical. But the facts should be coming from what I'm providing to you right here. And each one of the facts has a score to decide that's telling the model how important or relevant that fact is. Furthermore, in our way for how we retrieve these facts, we make sure that these facts are covering multiple points of view. And that's how we minimize bias, right? So we don't just get the most 10 most relevant facts, period, because that might be all representing only one way of seeing things. We try to add some diversity in the result set that is coming back so that we can minimize bias. And this way, when this model now processing the response, you get back the perfect response.